Today, we're going to discuss experiment 1, chemical reactions and the net ionic equations. The objective for experiment 1 is to predict the products of some displacement reaction and write net ionic equations. Here is one example. We used this example last time in our net ionic equation discussion. Remember, we have different reaction types: combination, decomposition, single replacement, and a double displacement. The focus of this experiment 1 will be the double displacement. That's the reaction type involves the exchange of elements or ions in two compounds. In this experiment, we have 3 parts. The first part is the solubility of compounds in water and acid. The second part is to review the concept of an electrolyte. And third part is to run a couple double displacement reactions and write down the net ionic equations. So let's look at the first part, the solubility of a compound in water and acid. In this part, there are 2 steps. First step is to test the solubility of a compound in water. And the second step is to test some compounds, not all, some compounds, 1, 2, 4, 5, 7, their solubility in acid. So here is an example. I use the calcium phosphate here. So I guess a little bit of calcium phosphate and put that in the water in a test tube. After I shake it, you can see the solution in the test tube is turbid, right? It's white, cloudy suspension in there. That means the calcium phosphate is not dissolved in water, right? That's the first step to test the solubility of this compound in water. And then the second step is to add nitric acid into whatever I have in the first step. So just add the nitric acid, 6 molar nitric acid, into the same test tube. After I shake it, so you can see the solution become clear again, right? That means the calcium phosphate is dissolved in nitric acid. So in the template, you can download from the Canvas. So here, in the table 1, solubility of compounds in water, you can see I use this one as an example, calcium phosphate. And the lab results observation, the first one, solubility in water, I would say it's insoluble. And solubility in nitric acid, it's soluble in this case, right? So you will be provided with this table, and it includes different observations for different compounds. The second step of the experiment is to test electrolyte. We'll use this device. Basically, it's a battery, a switch, and a couple LED bulbs. This end is connected with the electrolyte. That will close the circuit, then you will see the bulb will get the light up. If there's not enough current, but just barely some current, then you'll see it's going to be a dim light. If there's no current at all, then there is no light. So this is an example. I have a nitric acid here. So this one is acetic acid, and this one is ethanol. So as expected, if it's a strong electrolyte, it must conduct current effectively, right? I should have a bright light. If it's a weak electrolyte, it just conducts a partial current compared to the strong electrolyte, then I'm going to have a dim light. If it doesn't conduct current at all, then I won't be able to get any light. So these observations are filled in this table. These 3 examples here: nitric acid, I got a bright light; acetic acid, a dim light; ethanol, there's no light. Okay, you'll be provided with this table too. Based on the observations, you need to figure out if this compound is a strong electrolyte, weak electrolyte, or non-electrolyte. The third part is to run a few double displacement reactions. In this part, there are two steps. So the first step is to mix two compounds together, that's step A. And the second step, another reagent is added to the same test tube after reaction A. Let's see an example here. So I have a barium nitrate and the potassium sulfate. So barium nitrate here, potassium sulfate there, and an empty test tube. So I add each of this solution into this test tube. And you can see there is turbid in the bottom of the test tube, meaning there is a participate forming after I mix these two solutions, right? That's first step, that's step A. And for step B, we add another reagent. So in this case, it's a hydrochloric acid, 12 molar hydrochloric acid. We add this acid in there and shake it. Then anything changed in there? There's not much change. So the participate remains, right? There's a two-step. In the table you are provided, you'll see that. So this is a reaction 1 with two steps, 1A and 1B. The first step is to mix the barium nitrate with the potassium sulfate. And the observation is a white solid forms. 1B will be barium sulfate and hydrochloric acid, right? So in this step, these two reagents will form barium sulfate, which is not soluble in water. And then in the second step, we add HCl into this barium sulfate. The participate remains. So we say there is no reactions. Okay. You can see there are 2A, 2B, 3A, 3B, with the exception of 6, 7, 9, 10, which is just one step reaction. And based on these, you will need to figure out what kind of a reaction is happening when we mix these reagents together. And you need to write down the net ionic equation. On the canvas, there is an experimental procedure provided. You can follow what's down in the lab. Lab report, that's the most important thing. A lab report with a lab report template with observations. So it has data table 1, 2, 3, that's solubility of compounds in water and acid, and the conductivity ratings for compounds. And the table 3, that's a double displacement reactions. That's all the observations. That's just the tables I show you in the previous slides. So what you need to do is to download the lab report template and fill out the lab report tables. You can use the data within the template and write the ionic equation in the space provided. Okay, everything must be typed. So when you type up the chemical formulas, make sure in your Word document, use the subscript and a superscript to type different coefficients in the formula.